a lot of questions.
No, it moves. It moves me out. Why? I need to write it.
This part.
No.
Can I take a picture of you doing that?
I already did it once. I'm not doing it again. It hurt.
Wait, what?
It hurt me. Why do you ask a young teacher in their 20s or 30s? Why do you want to ask a teacher in their 50s?
You're still more
Well, that's true. But it still hurt after.
Wait, everything that's right? No.
Who asked you?
Liu. KK Liu. If that's his real name. Hey, where's my worksheet? Somebody's. Oh, it's right there. Did you guys actually look at the examples this time, Zan?
Finished.
Yes, we. Okay, now that's being ridiculous.
I want to see.
7. Okay, 7. Just look at the graph though. 7 and 8. 7 and. Wait, how come 7's up there but 8 isn't? They like go hand in hand. Just look at the graph. Okay, what does the graph of y equal e to the negative, e to the x looks like this, so e to the negative x reflects over the y-axis. This is what the graph looks like. So what's the limit as x approaches infinity? 0. What's the limit as x approaches negative infinity? Infinity, right? Or even if you don't look at the graph, when you find the limit as x approaches infinity, plug in like a really huge number, like 1,000,000. What's the limit as x approaches negative infinity? Plug in like a really huge negative number, like -1,000,000, and see what you get. But some of you, your graphing skills are still not. How many times am I going to give number 12 before we get it? You guys don't remember doing this when we did sequences? Of course not. Why do I even ask? Okay, now sine x oscillates back and forth, but you keep dividing it by bigger and bigger numbers, remember? So this sine x always stays between -1 and 1, but then you keep dividing it by bigger and bigger numbers. So it's still oscillating back and forth, but the amplitude is getting smaller and smaller and smaller. So what do you think the limit is? 0. Don't you remember this from when we did the limits and sequences? Remember that? Keep oscillating, but the amplitude gets smaller. Why even ask for your trig? 13. ln x over x. Come on! N to the n Feppel. I gave you the same problem back then too. You guys are crazy. What do you do when both the top and the bottom both go to infinity? Use n to the n Feppel. That's logarithmic. That's polynomial. Here, logarithmic polynomial. Which one goes to infinity faster? Yeah, polynomial. So if the bottom is growing faster than the top, then it's 0. Have we forgotten n to the n Feppel? Well, obviously. 13, 16. Lomi! Limit x approaches infinity, x. Natural log 1 minus 2 over. Now, do not do this now. What's the limit as x approaches infinity of just that thing by itself? 0, because the degree of the bottom is bigger than the top. So 1 minus 0 is 1. Natural log 1 is 0. 0 times anything is 0. No, because that's going to infinity. Like if that was a 5, 0 times 5 is 0. But 0 times a number going to infinity is not 0. You cannot treat infinity like a number. So what do? You lomi. So the first thing you do is put this x in the front up as the power, and then hey, you almost somebody. So what do I do? 1 plus box over x to the x. So that thing right there, what's the limit of that as x approaches infinity? E to the box. So this gets closer and closer to e to the -2. So the whole thing gets closer to natural log of e to the -2, which is -2. Natural log of e to the gorilla is gorilla, of course. 16, 20, 22. Put 20 on the board. You just look at the graph. This is a base graph. Huh? Is this you, Zach? Is this your doing?
No.
Base. Just look at the graph. Is this Saito's doing? Okay, let me refresh your memory. This is the graph of sine. So therefore the graph of cosecant, you're going to be humping up and humping down. So what's the limit as x approaches 0 from the left? Okay, here's x equals 0, coming from the left. Negative infinity. That's a base graph. Next time I see a base graph up there, who knows what's going to happen? Yell out the door or something. Okay, 21 and 22 go hand in hand. What is the limit as x approaches 2 from the left and the right of... I told you guys how to do this yesterday! Boo! I'm going to give you the boo. Boo! Okay, what do you do? What's the first thing you do? You plug... What happens when you plug in 2 here? Plug in 2. Plug in 2. Negative 1 over 0. What? Mr. Park said something about that yesterday. If you have non-zero over 0, that means there's a vertical asymptote there. Which means, what? Coming from the left, there can only be 2 possible answers. Either it's going to go pokui or pakawi. It's either infinity or negative infinity. And how did I tell you yesterday how to figure it out? Plug in a number very close to 2 on the left, like 1.999. 1.999 minus 3 is negative. 1.999 minus 2 is negative. Negative over negative is positive, so the answer is positive infinity. And then without even doing any work, how do I know this one's negative infinity? Because when you have an odd power on the bottom, it's going to, if it explodes up there, it's going to explode down there on the other side. Remember that? And even if you don't remember it, then you just do the same thing. Plug in 2.001. Negative over positive is negative, so negative infinity, right? So even if you didn't know that, you can still forget it. Anyway, even if you don't know anything, like you don't even know this non-zero over 0 business. Let's say you didn't even know anything. What happens when you plug in a number very close to the left? Like 1.99999 minus 3. What is that? Negative 1, a little bit bigger than negative 1. And then what is 1.99999 minus 2? Negative 0.0000001. So what happens when you divide like negative 1.0000001 by negative 0.00001? You can get a really huge positive number, so then the limit is infinity, right? So even if you don't know anything, you can figure it out just by plugging in something. But of course, we don't want to resort to that. 25 and 26. I did examples like this yesterday. In fact, one of them is exactly. You guys like hearing that voice, must be. Limit x approaches 0. Why do I even do examples on the board? Oh my god. Okay, what's the first thing you do? You plug in 0. What happens when you plug in 0? You get 2 over 0. Okay, that's something, huh? Something Mr. Park said yesterday. What does that mean, 2 over 0? That means there's a vertical asymptote there. Non-zero over 0 means vertical asymptote. So coming from the right, it's either going to pakui or pakawi. It's either infinity or negative infinity. How do you figure out which one it is? Plug in a number very close to 0 on the right, like 0.001. What is cosine of 0.001? It's positive plus 1, so top is positive. What is sine of 0.001? Positive. Positive over positive is positive, so the answer is infinity. So that means it's pakui. Cross out pakawi. 1 minus cosine over sine. This was the same example I did yesterday. No, it was pi from the right, yeah. Excuse me. Change it. But it's the same thing. If you plug in pi, you get 2 over 0, which means there's a vertical asymptote there at x equal pi. So coming from the left, it's either going to be infinity or negative infinity. Plug in a number very close to pi on the left, like pi minus 0.001. Maybe you should look at the unit circle. Pi minus a little bit. That's in the second quadrant, by the way. What's cosine of a second quadrant angle? Negative. So 1 minus a negative number going to be positive, right? What is sine of a second quadrant angle? Positive. So what's positive over positive? Positive. So that's it. Positive infinity. And then the last two problems. Oh, very good. You did 27 and 28. You guys made piecewise function. So the next test is going to have 50 of these, 2 points each, all or nothing. That's what's going to happen. No free points. That's because this is to raise your grade. Or lower it. Limit as x approaches infinity of this. Now, this one's kind of, this how many people got it? Without, how did you think of it? Plug in numbers like about a million, and a billion, a trillion on your calculator? Try? Okay, you can, I guess you could try that, but then, I guess that would work. What about for negative infinity though? Okay, I'm going to teach you a trick. Okay, watch this. Doesn't this like hey, that's like, you owe somebody. Watch what I'm going to do. I'm going to complete the square. Is that even legal? Because if I add 1, doesn't that change? Yeah, but you can. You know why? Because we're taking the limit as x approaches infinity. When you plug in really huge numbers for x, like a billion, you get a billion squared plus 2 times a billion plus 1. That plus 1 is so insignificant, it's not going to change the limit. So you only can do this as x approaches infinity now. You guys understand? Like if x is approaching like 0, you couldn't do that. But since x is approaching infinity, you can do that. Now why would I want to complete the square? Because that is x plus 1 quantity squared. And what is the square root of gorilla squared? Absolute value of gorilla. How come not just gorilla? Because we were taught that since algebra 1, that's why. Now, what do you do when you have absolute value? You make a piecewise function. So as x approaches infinity, the inside is positive, so you just leave it alone. Ooh, the x's cancel out. You get 1. Finished. Now, of course, if you had a calculator, you could just plug in a billion and see what you get. Probably going to be like 0.999999, so you can probably guess it's 1, yeah? Yeah.
So we can just do that every time to complete this square.
If x is approaching infinity, though.
So if it's approaching infinity, you can just
Yes.
complete this square.
Yeah, it's like a trick. That's because this number here, even if you added a really big number here, that's insignificant compared to like really large numbers, right? Okay, now what happens, well, what about number 30 now? What happens as the limit as x approaches negative infinity? You do the same thing, except when you get to this step here, what? You negate it. So this becomes negative x minus 1 minus x. Remember? If the inside is negative, you negate it. And what does that simplify to? Well, this is negative infinity. Negative 2x minus 1. So what is the limit as x approaches negative infinity of this? Well, let me ask you this. What happens when you plug in a really huge negative number for x there? What's a really huge negative number times negative 2? A really huge positive number minus 1. It's a really huge positive number, so the answer is infinity. Okay, we were just doing a calculus problem last night. We were practicing for the AP exam, and this problem came up. I'm going to tell it to you now because probably going to have this on one of the 50 problems. So, f of x equals, what was it? I'm trying to remember the problem. 5 plus 3 to the x over 1 minus 3 to the x. What is the limit of this function as x approaches infinity? What is the limit of this function as x approaches negative infinity? Okay, let's see if we can think it out. What happens when you plug in a really huge number for x? Like a billion. Can you see that the 5 and the 1 are just insignificant? 3 to the billion power, it's so huge that 5 and the 1 don't even matter, right? So then what? Yeah, so what number is it getting closer to, you think? -1, because you have 3 to the billion over -3 to the billion. Isn't that like -1? Okay, now what about, what's the limit as x approaches negative infinity? Plug in a really huge negative number, like -billion. No. What is 3 to the -billion power? That's like 1 over 3 to the billion. What is 1 over 3 to the, what is 1 over super huge? Very close to 0. So that gets closer and closer to 0, that gets closer and closer to 0, so what's left? 5. This is AP calculus too. Okay, so tonight we do what happens. Oh, I get it. Okay, so last time we dealt with limits involving infinity. Now we're going to look at other kinds of limits. How do you compute the limit as x approaches like 1, 2, or 3? What do you do? Okay, let me give you a simple, this is so simple it's ridiculous. What is the limit as x approaches, give me a number, 2, of x cubed minus 7? Now, oh! Sorry, backtrack. Let me draw you a picture. First of all, you gotta understand what limits mean first, that's why. So, let's do 1, 2, 3, 1, 2. Okay, so here's -2, here's -3. Suppose we have a piecewise function that looks like this. 1, 2, 3, 1, 2, 3. So this is 3 and -3. So let's say we have a piecewise function that looks like this. And then and then okay, here is a piecewise function. What if I ask you this question? What is the limit of this function as x approaches -2 from the left side? Okay, here's x equal -2 right here. Coming from the left, like here. The y coordinates are getting closer and closer to what number? 1. Because the graph is getting closer and closer to this point right there. And what's the y coordinate of that point? 1. What is the limit of this function as x approaches -2 from the right? So coming from the right, the y coordinates are getting closer and closer to what? 1, because the y coordinate of that point is 1, right? So if we call this the left-hand limit, this is called the right-hand limit. If the limit from the left is 1, and the limit from the right is also 1, then the limit of this function as x approaches -2 is 1. In order for a limit to exist, it has to approach the same point from the left and the right, and it is. It's approaching that point. The y coordinate of that point is the answer. Yeah, but Mr. Park, there's no point there. Yeah, this is as x approaches -2. We don't care really what happens when x is 2. We only care what happens as x gets closer to -2. So even if I put a dot, like if I put a dot there, is that going to change the limit? No, because coming from the left, it's still getting closer to this point, and coming from the right, it's still getting closer to that point, so that's why the limit is 1. I can put this point anywhere. I can put it here, the limit is still 1. I can put it there, the limit is still 1. I can put the point there, the limit is still 1. Or I cannot have any point at all, the limit is still 1 no matter what. In order for a limit to exist, it has to approach the same point from the left and the right. The left-hand limit and the right-hand limit have to be equal. Okay, now let's move on over here. What's the limit of this function as x approaches 3 from the left side? Okay, here's x equal 3. Coming from the left, the y coordinates are getting closer to what? -2. What is the limit of this function as x approaches 3 from the right side? Okay, now coming from the right side, the y coordinates are getting closer to +2. So this is the left-hand limit, this is the right-hand limit. So therefore, what is the limit of this function as x approaches 3? Take the average. No, the limit does not exist. In order for a limit to exist, like I told you, it has to approach the same point from the left and the right. But over here, is it approaching the same point from the left and the right? Yeah, if you make a really long point. Some of you, oh yeah. No, you can't make a really long point. So that's why the limit doesn't exist. So again, if you have the picture right in front of your face, it's easy to figure out limits. Like right here. Let's put the hash mark right here. What if I were to ask you, what is the limit of this function as x approaches 0? Okay, here, coming from the left and the right, is it going toward the same point? Yeah, what's the y-coordinate of that point? It's -1. So if you have the graph right in front of your face, easy. Now the problem is, okay, how do you compute limits quickly without drawing the graph? That's what you have to do in your homework. Okay, so here's the problem I had the first time. I can't even remember what I did. A limit x approaches to x cubed minus 7. Okay, without drawing this graph, how do you think I can compute this limit? Yeah, you simply plug in the number. If you can plug in the number and get something, that's the answer. So if I plug in 2, you get 2 cubed, which is 8. 8 minus 7 is 1. And you know why that works? Because if you were to draw this graph, which is the cubic graph shifted 7 units down, or something like that, isn't the point 2, 1 on that graph? And that's why it works. So if you can plug in, and look, coming from the left and the right, it's going toward that point, right? If you can plug in a number and get something, that's the answer. Now, how many of these do you think you can get on the test? Probably one. No, you can get a lot. You can get one, maybe. Anybody can plug in a number. But see, you're not going to get, like, come on, this is pre-calculus regular. This is pre-calculus honors. This is what you can get. What's the limit as x approaches pi over 6 of cosine x over 2? That's the kind you can get. Okay, pi over 6. Plug it in, so you get cosine of pi over 12. Root 6 plus root 2 over 4. Remember I taught you the math team secret? No, what about the rest of us who don't even know what math team is? Then, to compute the cosine of pi over 12, you either use a half angle identity or a sum and difference identity. Write this as what? Pi over 3 minus pi over 4, and then expand it, right? That's the kind you get in honors. You don't get these stinking pre-calculus regular kind. Okay, let's look at more examples. Because you got to get good at this. Okay, what is the limit as x approaches 1 of x squared minus 1 over x minus 1? So the first thing, as x approaches a number, the first thing you do is plug in the number. Because if you can get something, that's the answer. If I plug in 1, what do I get? 0 over 0. Now, last night's homework, non-zero over 0 means a vertical asymptote there. Okay? But if you get 0 over 0, that means we call this indeterminate. Indeterminate means we don't know what the heck the answer is. We gotta figure it out. So there are several techniques that we use. Okay, one is just simplify. Is there a way I can simplify that? Yeah, it's called factoring. You factor the top. You factor the bottom, which it already is, and then, oh, I can cancel! Now, can I plug in 1 and get something? Yeah, you get 2. You know why that works? Why does that work? I don't know, but Mr. Parker just does. Because if I ask you to draw this graph, what would you do? Wouldn't you factor and cancel? Which means you just graph that, y equal x plus 1, which is a straight line. But since I canceled that, then there's going to be a removable discontinuity there. Right? So, coming from the left and the right, it's getting closer and closer to that point. What's the y-coordinate of that point? 2. That's why it works. Okay, so the first thing you do, if you get a 0 over 0 indeterminate form, the first thing you should try to do is simplify it. Okay, now there's lots of ways of simplifying. Factoring and cancel. So you know you're going to do synthetic division tonight. What? Because that's how you factor when it's cubic. Or higher. You do synthetic division. No! Okay, here's another technique. What's the limit as x approaches 0? Silence, I must think. 1 over, silence! 3 plus x, I hope this is not one of the homework problems, minus 1 over 3 all over x. Okay, what's the first thing I should do? Plug in 0. What happens when I plug in 0? You get 0 over 0. That's indeterminate, so that means I gotta try something. Simplify, try simplifying. What? How do I simplify this monster? If you subtract fractions, what do? You make a least common denominator. What goes on the top? 3 minus 3 plus x. And then when you divide by x, it's like multiplying by the reciprocal, right? Okay, limit x approaches 0. Okay, what happens when I distributize that negative sign? 3 minus x, all over 3 times 3 plus x times x. Hey, the 3's cancel, and this x cancels that x, so all you're left with is negative 1 on the top. Now can I plug in 0 for x? Yeah, what happens when I plug in 0 for x now? You get negative 1, 9. So the first thing you try to do is simplify. Okay, then let me show you another simplifying one. What is the limit? Give me a single digit number. 2 of root 4x plus 1 minus 1 over x minus 2. Okay, there you go. First thing you do, plug in the number. Wrong. This is a 3. Okay, plug in the number. 0 over 0. What does that mean? Indeterminate. In fact, pretty much all tonight's homework is all going to be indeterminate. So you got to do something. Now, Mr. Park, how do I simplify something like that? Well, when you have a radical, what you do is you try multiplying by the conjugate. Yeah, but Mr. Park, so I thought we only do that when the radical's in the bottom. Well, welcome to calculus, people. It doesn't matter where the radical is. You multiply by the conjugate, which is that plus 3. So remember, multiply top and the bottom. You can't just multiply something, just the top or the bottom. Okay, now, why do I do that, Mr. Park? Because look, good things start happening. What happens when you multiply these two? What do you get? 4x plus 1 minus, what? Minus 9, which is the same thing as 4x minus 8. Some of you can have foresight. Can you see it already? What's foresight? Factor out the 4. And then on the bottom you got this. These cancel out. Now can I plug in 0? Yeah, what happens when I plug in 0 now? You get 4 over 3 plus 3, which is 6, and of course that reduces to 2 thirds. Yeah. That's because it's 2. And so you get 4 over 2. Because you're plugging in 2, that's why. How come I was thinking 2, but there was a 0 there? Okay, so does everybody understand? The first thing you do is you try and simplify it. These are the different techniques of simplifying. Okay, let's look at another one. Okay, now we are ready to kick things up a notch. These are your basic ones. That's the ones you get in AB calculus, okay? We're not preparing for AB calculus. What's the limit as x approaches 0 of sine x over x? What's the first thing that you do? You plug in the number. What happens when you plug in 0? 0 over 0 indeterminate, so I gotta do something. So Mr. Park said simplify. Cancel out the x's, the answer sin. If you dare do that, you can't cancel out that. So what do? What can I do? Anybody? Change sine x to what? Square root of 1 minus cosine squared. But that's absolute value of sine x. Thank you. Power series. So now you gotta remember, so whenever you see those 5 things that you have the power series for, you gotta keep that in your back pocket. What are you talking about, Mr. Park? I hate power series. Well, I tell you what, I love power series. What's the power series for sine x? Let me just call on somebody at random. Miyoko. Okay, that's good enough, because once you know the first 2, you can figure out the pattern, right? Now, okay, some of you have foresight. Can you see it? Okay, and when you divide by x, isn't that just like dividing each term by x, lift and separate? Okay, so x over x is 1. That divided by x is x squared over 3 factorial. X to the 4 over 5 factorial minus x to the 6 over 7 factorial, and this thing goes on forever. What happens when you plug in 0 for x? That's 0, that's 0, that's 0. Everything is 0. What's the only thing left? 1. The limit is 1. Power series bails you out right there. So if you get a 0 over 0 in indeterminate form, okay, what are the 5 power series you know? Sine x, cosine x, e to the x, tan inverse x, natural log 1 plus x. That's when you use power series. But this limit is so famous in calculus, we just memorize it. From this day forward, whenever you see sine x over x and the limit is x approaching 0, the answer is 1. Just memorize it. This is your friend here. We call this friend because it comes up so much in calculus. We just have it memorized. Now, do not fall into the pit, the easiest trick in the book, right here, like this. What if I give you this problem? Sine x over x. This is every year. This is the students who don't do their homework. They go, friend, 1. No, that is not friend. You know why it's not friend? It's only friend as x approaches 0. You can't just look at that. You got to look at the number x is approaching. This is not friend. So what do? The first thing you should do is plug in the number. What happens when you plug in pi? You get 0 over pi, which is 0. This is not friend. You guys understand? It's only friend as x approaches 0. Okay, so let's do some math. I just want to make sure you know that. This is probably one of the homework problems, but that's okay. Okay, what do? Plug in the number, I get 0 over 0. So now usually when you have a trig function, what you want to do is you want to look for friend. Does anybody see friend here? I don't see friend. Well, if you use identity, what's identity for sine 2x? 2 sine x cosine x all over x. Does anybody see friend? Right there, that's friend. The limit as x, why is that funny? The limit as x approaches 0, that gets closer and closer to 1 because that's friend. What about this thing? Well, what happens when you plug in 0 here? What is cosine of 0? So this is getting closer and closer to 1. So the whole thing is getting closer to 2 times 1 times 1. 2 is the limit. Now there's 2 ways of doing this problem. Here's another way. Now, when you do the harder problems, instead of thinking of this as x, you might want to think of this as box. You know what I mean? So, another way to think of this problem is, I don't care which way you do it, sine 2x over x. What you can do is, okay, this is box, but in order to have friend, I have to have box on the bottom, right? So what can I do to have, put a 2 here? You multiply top and bottom by 2. So now you have sine box over box. But that doesn't guarantee that that's friend. The box has to get closer and closer to 0 in order for this to be friend. So I have sine box over box, but is the box getting closer to 0? Well, as x gets closer and closer to 0, does 2x get closer and closer to 0? Yes, so that's friend. That gets closer to 1, 2 times 1, 2, which of course is the same answer. So there's 2 ways you can do it. Okay, let's look at another one. What's the limit as x approaches 0 of tan x over x? Okay, plug in the number 0 over 0, it's indeterminate, so what do? Look for friend. What? Yeah, but Mr. Park, friend is sine x over, I don't see sine here. Change tangent to sine over cosine then. And when you divide by x, that's like multiplying by the reciprocal, so the x actually goes in the denominator. Do you see, friend? Yep, right there. And sine x over x is approaching 0. That's friend, that gets closer to 1. What about this? That gets closer to 1. 1 divided by 1? 1. Friend is good. Oh, you guys think you're good now, yeah? Let's kick it up a notch. Limit. See, that's the kind you get, easy kind in AB. In BC, you get the higher level ones like this. What's the limit as x approaches 0 of 1 minus cosine x over x squared? Okay, what happens when you plug in 0? You get 0 over 0. It's indeterminate. So I see a trig function. I'm going to look for friend. Yeah, but Mr. Park, friend has sine. I don't even see sine here. There you go. Multiply top and bottom by a conjugate. Oh, so that's kind of an important skill, Mr. Park. No. Now, why do I multiply by conjugate? Because that's 1 minus cosine squared x, and that's sine squared x. Woo! Do you see friend now? Well, not only do I see friend squared. Right? Because this is friend, but then it's squared because that's squared and that's squared. So it's actually friend squared. And then don't forget, to, everybody gets excited and they forget about that part. Don't forget about that. Okay, so that's friend. That gets closer and closer to 1, right? Friend squared. But what about this? Well, what happens when you plug in 0 here? You get 1 over 1 plus 1. That gets closer to a half. So therefore, the whole thing gets closer and closer to 1 squared times a half, which is a half. So if you don't see friend, you gotta lomi and make friend. Is that funny? Okay, now you think you're good. Okay, now here we go. Kick it up. This is what we do in BC calculus. Limit x approaches infinity, x sine of 1 over x. This is the one that separates the sheep from the goats. Now, can I do this? As x approaches infinity, this gets closer and closer to 0, correct? Okay, sine of 0 is 0. So 0 times anything, 0. No, that's because that's going to infinity. In fact, that's another indeterminate. Here are the indeterminate forms. You got 0 over 0, infinity over infinity. You got 0 times infinity. You got infinity minus infinity, 1 to the infinity. These are all indeterminate forms. So no. You can't go 0 times something is 0 because that's not a finite number. That's going to infinity. So what do? You look for friend. What? Okay, now, what can I do to make it look like friend? Watch this. Sine box. If you have an x in the numerator, isn't that like a 1 over x in the denominator? That's called lomi. Sine box over box. Okay, but that doesn't guarantee it's friend. You have sine box over box, but in order for it to be friend, the box got to go to 0. Yeah, but Mr. Park, it says x, I don't care what x is approaching. Is the box going to 0? As x goes to infinity, what's happening to the box? It's getting closer and closer to 0. So this is friend. The answer is 1. Sine box over box, and the box is getting closer to infinity. This part doesn't matter. The box has to be going to infinity. That's friend. So that's 1. See, you guys would be befuddled by that, right? But that's, you gotta be, see, in AB, we don't even get anything close to that. Even this, multiplied by conjugate is just foreign to us. You just gotta know friend in AB. Okay, so tonight's homework, be prepared to do synthetic division. You got it. Okay, we don't want to give it away for the next class. So that's the end of the lectures for this chapter. You just got to get good now. You got to get good at limits. Because if you can't do limits, you can't do calculus.